I thought I'd start off trying to define briefly what a technology mineral is, since that's part of the name of the conference and it wasn't clear to me exactly what that meant. Efficiency can come about in many ways, and being lighter or stronger and faster seems to sum up a lot of materials improving their efficiency. Things becoming conductive electrically or thermally, for that matter. And of course, affecting the sustainability of current materials, improving them, can be a big advantage as well. So to me, there's many minerals that we work with on a day-to-day basis that can fit into that. And certainly that's what were some of the drivers behind Talga going into graphite back in 2011 up in Sweden. And in early 2014, doing a bit of work that discovered we had a really significant way of making graphene super cheap from our ore. So we've headed into that space with great results. Also, speaking of technology minerals. So Talga's an advanced materials company. We're vertically integrated. A little known fact is that we're not only mining material in a trial mine up in Sweden, we're processing it in a pilot plant facility in Germany that we built ourselves. We have nearly 20 people now based in Europe, with over 15 of those in Germany. And we're also developing products. We've actually got in-house scientists. So we're listed obviously on the ASX here, but for our international audience that may be watching this, it's code TLG. We also are expanding that product pipeline. That's an interesting part about what we're doing going forward. So Talga's based now on three main factors that give us a distinct advantage. So the first one is, starting at the beginning, is the actual source itself. It's the highest grade graphite resource in the world. Under JORC or NI 43 conditions. It's also a very unique sort of ore, as I'll show you soon. It forms natural electrodes, so we don't crush and grind our ore, we actually carve it out directly into electrodes we use in electrochemical processes, and it's in Sweden. Sorry, I think I'll just watch the screen from here, sorry. Sweden is a jurisdiction that has got fantastically low taxes and minerals tax royalties, and it's got super low power costs, and it's directly connected by road and rail into Europe, including Germany, some main markets out of there. We've developed a process. We've taken something that was in the marketplace and enhanced it, and this replaces crushing and grinding, so the ore itself does not need drilling and blasting, which reduces dust and environmental impacts. It allows you to get hold of the ore in a very clean way and then make some really high value added products out of it. So that's what we're currently doing now over in the UK. So we've got a pipeline of deposits and now products coming into play. And some of these sectors are far bigger than the global graphite market. As you just heard from Andrew, the natural graphite market consumes about 1 million tonnes per year. I should point out that the global paint and coatings industry consumes over 40 million tonnes a year of materials. So this is what we're actually going after with our materials. So some of our material can play in the current graphite market, but we're really excited about developing products for the much larger industrial product markets of the world. So let's start with this process just to try and grab your attention at this late stage of the day. So what you're about to see is a very basic video shot a couple of years ago that we released late last year, showing the basics of what we're doing when it comes to the processing of the material. So what are we talking about? We're talking about a graphite deposit that's 60 kilometres long. It's on average 20 metres wide. It ranges up to 50 to 100 metres wide. We've drilled about 2% of that and turned it into a JORC resource. And that rock, you can pick it up from the surface and put it into a liquid, which in this case is about 99% water. And we can run an electric current through it. So if any of you are interested in what that is, it's less than 12 volts. And what you see happening to the rock is it's not dissolving, it's exfoliating. So what we've done is designed ions in the water that are just the right diameter to be intercalated in between the layers of the graphite, and we drive them in there and then we split the graphite apart. So we can reduce 7-tonne blocks of rock down to individual atoms with no crushing and no grinding. And as you can see, it's a very scalable process. There's no increase in temperature required. It's not in a stainless steel vat under pressure. It's just sitting in a glass beaker. It's fairly low current. and we're just using, in this case, a piece of rock we picked up from the surface. It doesn't require special pre-treatments. Now, some of that black stuff floating around in the liquid is single-layer graphene, and then there's a distribution of few-layer graphene, graphene nanoplatelets, and micrographite, very fine-grained graphite that we can produce. So the average size of these particles is down around 10 microns or less. That's with no crushing or grinding energy. And some of these particles are extremely high value. So that's what we're doing. It only works if you've got the right type of ore, the right type of rock that allows this to happen. In our case, and with my position at some of these unis over in China, I've been sampling deposits around the world, including everywhere you've heard about in the earlier presentation. And we know what works and what doesn't. Otherwise, we would have gone somewhere else and done something else. We're very happy with what we've got here. Works very, very well. The company itself, we've owned recently with the Smedvig Group, is a large Norwegian family office. Peter Smedvig, based on oil and gas money, servicing money from oil and gas rigs, is our major shareholder. I'm the second largest shareholder, so I've got some skin in the game. Some of you may recognise a famous prospector down at number 4. And so we've got a predominantly high net worth and family office and some institutions in the stock. 50 mil market cap at roughly our current price, 4 directors, and just over $10 million in cash at the end of the last quarter. My background is in the minerals and mining industry, but it's also in science. I spent quite a bit of time working on dinosaurs, where I specialised in the conversion of organic residues into stone. Funnily enough, our graphite deposit, of course, is an ancient 1.8 billion year old fossil, in that it's a layer of dead algae that got converted into graphite. So in some ways I feel like I'm still doing paleo. Keith Coughlin, who you'll see later on in this conference, is working in the lithium space as well. Grant Mooney used to be chairman of Carnegie Wave Energy, still involved there, has got high-tech experience. And Steve Lowe, some of you may know, is the ex-chairman of Sirius, the ones that found a nice nickel copper deposit here in West Australia that was commercialised recently. So here's our triumvirate. So we're mining the carbon source in Sweden, which we own 100%. We're currently processing in Germany because it was very close to some of our processing and research partners, and plus the Thuringian government gave us a fantastic deal on all sorts of grants and other things that are possible to do in that part of former East Germany and central Germany. And then we're also starting Talga Technologies in the UK, which houses our product development team. And insofar as that, the operations in Sweden and Germany are headed up by the ex-commercial manager of Iluka, Mr. Martin Phillips. And our Talga Technologies, our product development, is headed up by the former chief of graphene products for Tata, the Tata Group, and that's Dr. Shiva Bohm, who's here on the right. So our business model to make money is not just raw material supplies. It's to add value to the products and develop graphene-enhanced products. We build a prototype, then we patent it or choose not to, and we then send that to companies for testing. And on the basis of getting a deal with them, we'd look for licensing revenue, and then they would produce something under license for us and drive the raw material sales as well. So at this stage of our development, that's what we're focusing on. We've got 4 sectors, because graphene in particular, apart from graphite, has thousands of uses. Graphene has millions of uses. Graphene can influence positively almost every material that you see in the world around you. So we've narrowed it down to 4 sectors based on their scale, but also the speed to market. So you'll notice that some of these are not biomedical applications. They're not really tricky high technology applications. They're basic, but they're big volume, and they can be brought to market fairly quickly, and the margins actually are very high. For example, particularly in coatings, obviously batteries, we've got a 2-pronged approach to that. I'll talk about conductives and the building market. We've got a range of technical and commercial partners underway, and something to keep an eye out for is not who our partners necessarily are, but who their partners are. So these guys might represent the front end for the product development of a much larger company that sits behind them or is a shareholder of them. So where do we fit in? Most products can be enhanced with graphene, but we want to make sure it fits on standard current production lines and make them real-world products. So we're not trying to do bendy televisions. We're not trying to do transparent electric flying airplanes, okay? What we're trying to do is make a paint coating that goes on the hull of a ship that is 300% better performance than it currently is now and saves you 20% of your fuel costs. Okay, we're trying to make a battery last 50 to 100% as long, or charge 50% faster. We're not trying to make one that's 1,000 times better. That will all come in time, but we're actually commercialising as fast as we can. And where we step in with graphene is a lot of these things have been worked out over the last 10 years, but no one could supply the stuff in any volume. So that's where we come in. We lower the price, we lower the volume, and like carbon fibre, like plastic, if you want to go back even further, like aluminium, when you lower the price of production, the volumes come up because your applications increase. That's what's underway now. We're a bit underrated insofar as that we own 25 different deposits in Sweden. So we're not just have 1 or 2 or 3 deposits. We've actually got a full range that go from predominantly plus 600 micron jumbo flake deposits all the way to the micrographite deposits that do these some of these crazy electrochemical things and suit graphene. So we've got 3 JORC resources that are substantial, the largest graphite resources I believe in Europe and the highest grade under JORC or NI43 in the world. And people probably also don't rate our JORC compliant exploration targets, which are based on outcrop workings, drilling. You know, it's not just EM targets, they're actually real physical data behind that, which is nearly 250 million tonnes or up to 250 million tonnes just in the top 100 metres. So there's a huge amount of supply available. We've specially chosen the ones that we think will commercialise the most rapidly for the biggest bang for the buck. So with this Vittangi project, the Nurmesvara deposit in particular, the high grade one, we've worked out, we proposed back a couple of years ago that we should be able to cut the ore directly into electrodes, and so that's what we do. I've got a video of that happening here. And what we've done over the last 2 years is run a trial mining test pit where we've scaled up the cutting technology. It's quarrying, obviously, but no one actually was sure how this would work. Can you cut at commercial speeds? Do you generate heat or use the blades up faster than you should otherwise? Here you see a nice nearly 3 metre diameter dual wheel cutting machine. So you can imagine having essentially a herd of those, 15 machines we've calculated can pull 250,000 tonnes per year over about 7 months if you wish. And we just pull the ore out as whole blocks because that is an electrode. So we're not going to crush and grind it. We're going to use it directly the way it is. We currently are storing the material in a shed, which, because we're in this logistically rich area of Sweden, we have a shed with a railway track going through it, and we can store all we want. We've backfilled the site for this year. In fact, we've just extracted the maximum allowed under our permit. So I think you could admit that's a slightly different way of going about it. Here's what the process looks like then in a cartoon. Solid ore going up to exfoliation with electricity and chemistry, brings out the products. So it totally physically comminutes the ore down to miniature particles, and we produce micrographite and 2 types of graphene, including very high value few layer graphene. So it's got some benefits, no crushing, no grinding, and you get a whole range of very thin particles which are worth a lot of money. And normally it's because they're very hard to make. It takes a lot of energy actually. So here's what the graphene looks like. Here's some single sheets. Single sheet, here's another sheet over the top of it. And here you can actually see 4 atom thick sheets. So each one of these lines is a layer of carbon atoms, crystalline carbon. And this texture up here you can see across the top of the sheet. If you look closely, you'll see the characteristic honeycomb hexagon shapes. So we have individual atoms there hanging together in a sheet. So that's been produced from that rock with no crushing or grinding at a very advantageously, should we say, scalable and relatively low-cost way. And of course, compared to standard graphite production where you're crushing and grinding and floating, and you go through a whole series of stages to get to a product, for example, like a spherical graphite material, what we do is we exfoliate, we concentrate it, and actually we disperse that and make an anode out of it just the way it is. We don't bother spheronizing for our battery materials. We're now optimising that material, but currently it's already producing about the same capacity and performance as current material, but at much lower costs, much lower impacts. So on the battery materials, we currently have got material already that's been made into anodes and is now scaling up at the Energy Innovation Centre in the UK, and the results have been extremely good considering this sort of material is not optimised. And I just want to point out from our visits and work in some very large graphite companies in China, like this one here in the south of the country, is that the nice thing about graphene is behind most of the evolving battery technologies. So if any of you are worried about anodes one day converting to a different type of technology, if you're worried about spherical graphite, one day a battery technology comes along that doesn't use spherical graphite in an anode, one of the ways to actually hedge against that is to have some graphene, because graphene is behind lithium sulfur, lithium aluminium, lithium air, and also you can do printable batteries and flow batteries out of it. So you've got exposure across the full group of battery technologies that are underway. And another aspect that you get a bang for the buck out of your graphene from is that if you look at the regulatory pressure on cars to have less emissions, which is predominantly people see as a battery story, you can see the severe pressure that is still evolving by governments to push down emissions, is that not only is it an electrification story, it's also a light weighting story. So the carbon fibre bodies coming in, you have to look at lighter weight coatings, more efficiency across a range of things, tyres with lower rolling resistance, less weight, things like that. So graphene, which can go into wiring, fluids, tyres and coatings, can actually have a role across all sorts of different parts of the car. And that's really an example of it. Here, you've got over 2 kilometres of electrical wiring in a car that's currently made of copper, weighs about 60 kilos in some of the upper-end Mercedes cars. So graphene polymers, so these are conductive inks that can be printed onto plastic, replacing 60 kilos of weight, combined with a few other things, can essentially save one passenger's weight in a car, which affects its range. The number one thing to do with EV take-up is range anxiety. So whether it's Daimler or whether it's someone else that's doing more mass production of cars, or Volkswagen, they are actually very, very concerned with weight, and there's lots of areas here where graphene fits in. Over 150 different electrical devices, and of course, never mind the fact that there's 3 billion tyres a year consumed, which contain currently carbon black, which is why they're black, and it also contains wires with all sorts of different metal coatings, all of which could be improved and already have been shown to be improved. In fact, there's graphene batteries commercialising graphene tyres commercialising for sale right now in China, and on the wire side, it's getting really interesting. That's, I think, $230 billion a year just in tyres alone. So graphene, you get to play with all of it. So what's it got to do with us? Well, we've actually made some of this stuff. So our in-house scientists are taking the graphene products we make out from the graphite and they're functionalising it, which means they're adding chemical groups to it so that it can actually stick onto surfaces and do all sorts of crazy things. Like, so you've got things that weren't conductive now are, or something that was very heavy is now very light. So we're actually doing it in-house. These are the results of some of that work, where here you see no graphene after 288 hours. It's very corroded. 5% Talga's graphene after nearly double the amount of time, less corrosion. Nearly a 300% increase in corrosion performance. That's in that nice big 120 billion coatings market, of which the anti-corrosion part is an 11 billion part of that market. And that was just published recently. So we've got peer review scientific journals putting out the technical work, which then supports our approach to very large companies in this space. This is their annual sales in billions of dollars, and you can see some of the markets we're attracting. And so that's why we're in those markets. They're actually bigger. They're bigger than batteries by far, and actually the margins, frankly, on some of those materials are much better too. In the solar side, we've got conductive inks. Currently, there's a huge amount, 78 million ounces of silver going into hybrids with carbon black on making conductive inks. If graphene can actually, and it can at the moment, outperform some of that material, so we just need to commercialise up that conductive ink material and you'll start getting market share of that. You also use the same things for the Internet of Things, for RFID packaging, wearables, and as I said there about the conductive plastics and stuff for the automotive industry. So you can affect the performance, all of those, with this still graphite, but you've just reduced it to a super thin form. But you've got to do it at volume, and you've got to do it at the right cost. One of the other things we're working on is essentially snow and ice-free concrete. Why the heck would you? Well, don't need any down here in Australia, that's for sure. But up in the northern hemisphere, if you offer a guy a snow-free driveway who lives in Scandinavia or in Canada, it's quite a nice juicy deal. In Germany, it's actually legislated you must keep the driveway, the footpath in front of your house snow-free. So there's some actually quite big markets there. Airports in particular, the aprons around the plane where they load them and stuff is a very powerful place to put this sort of materials. So we like that. The pilot plant's scaling up. Of course, sorry I can't show you the inside and all the nice, interesting machinery and machines that go bing behind that story, but here's some of the graphene in dispersion. Essentially, it looks like black ink. These are some of the highest concentration dispersions of graphene I know of, and superb quality. So we're continuing to scale up so that we can make bigger and bigger samples. We also have a very high input ratio now, so 76% of our carbon we put into the process can be converted into the graphene, and so we use these to give to samples to customers, and that's on our commercialisation path. Here's only part of the team, and I guess we're expanding that team with our new operation starting up in the UK, and we're starting to deliver bigger volume products to these large customers. We're continuing to increase the scale of the plant because along the way some of these commercial partnerships will require larger volumes, and of course we're permitting for larger and larger mining operations in future, and we're testing how we can bring forward revenue through that development process. And a little known fact is that we still own some gold and some iron ore and some cobalt assets. In fact, we own Sweden's largest cobalt deposit, so we're looking at working on that. So right now I'd say Talga's worth a good hard look. It's been good presenting to you today. Thank you.